Vanuatu earthquake, December 16, 2024. California earthquake, December 5, 2024. Both of these earthquakes are considered as big earthquakes. However, their intensity in shaking is not the same. Take note of these two maps here, both provided by the United States Geological Survey. What it is that we can see is that Vanuatu, specifically the area most devastated, has a zone that will pinpoint it in the range of severe ground shaking. In California, the area of Fortuna, as example, experienced severe shaking. What I should add is the relative distance of the epicenter of these earthquakes relative to the areas that have experienced the most intense shaking. In California's case, the epicenter was approximately 300 kilometers from the coastline. In Vanuatu's case, the epicenter was approximately 50 kilometers from the coastline. This reality, as we can see, is one of the key factors behind why we would have witnessed such damage and intense shaking in Vanuatu's case relative to that in California. Secondly, is the fact that the population density of the areas of mention are different. Take a look at these two maps on your screen. Port Vila, Vanuatu on the right. Fortuna, California on the left. As we can see, there exists a significantly dense population in the area of Port Vila relative to that of Fortuna. Port Vila experienced severe shaking. Fortuna experienced severe shaking also. However, the outcome in terms of damage is different because of the population density factor. Let's now take a look of the geological map that this island in Vanuatu experienced the most severe shaking. To the map on the left, you'll notice the areas in yellow. Those areas are considered as alluvium. Port Vila and Melee, which experience intense shaking as well as significant damage, are situated on alluvium. Considering that these areas are relatively at sea level, we have to take into consideration that there exists high water table. High water table, significant shaking, liquefaction. Basically, quicksand, and a key ingredient for damage to buildings. Take a look at this Google terrain map of the area in California hardest hit during the December 5, 2024 earthquake. Fortuna partially exists on an alluvial plain. Consider as well that surrounding Fortuna exists rugged terrain. These areas of rugged terrain absorb the earthquake energy much better relative to alluvium. In other words, what it is that we would have seen, or what we can see on the California shaking map, where we see that there does not exist that great spread of the severe shaking. This has to do partially because of the terrain itself. So in essence, geology and geomorphology are other factors that are very critical in terms of explaining why there may exist intense shaking within a zone. At this stage, you should have a better understanding as to why two similar earthquakes in magnitude can have two dissimilar outcomes in terms of effect: distance to epicenter, population density, and geology, geomorphology. These are things you should be aware of and you should be consistently assessing when it comes to you looking at the disaster preparedness capacity of a community, of a region, of a country.